Okay, guten Tag, meine Herren und Damen. Now you've heard all my German. Other than zwei Bier, bitte. It's a pleasure to be in Berlin. It's a pleasure to be talking to data modelers, although I often make a joke about data modelers. You know the joke? I'm sure you do. The difference between a data modeler and a terrorist? You can negotiate with a terrorist. Yeah, we change the words whenever we need to. So today's topic is a very general, a very high-level topic. I did put in the word models because I thought that's what I needed to attract you in. I do occasionally talk about models as we go through the presentation, but actually I got sort of sidetracked about which models they were. So we'll see how that works out as we go through the presentation. So let us begin. About 63 years ago, in Chicago, a group of scientists came together in an old, converted volleyball court under Stagg's Field, which was a football field in Chicago University, in the city, way back then. And they were celebrating success in a particular venture, in a very important way in science. They cracked open a bottle of Chianti, which they had bought a few months previously. And in those days, a celebration was different. They got some paper cups from the canteen. They poured some very small amounts of Chianti into the bottoms of the paper cups, and they raised them, and they said, "We've made a success." There was no whooping, there was no sort of American cheering, because I think these folks, these ladies and gentlemen of science, were very aware of what they had done, of what they had created, and the possibilities and the dangers that lay with it. I'm sure you're beginning to think or remember what it probably was. So first of all, let me give you a little bit of physics. Any physics graduates here? Okay, can you correct me if I go wrong? Please, because my physics is very old and yours looks like it might be too. But anyway, here we have a picture of a fission reaction. What you see here is a neutron coming in here on the left-hand side. It collides with a nucleus of a uranium-235 atom. When that happens, the atom splits in two, it fissions, and it releases a whole lot of energy. But more interestingly, it also releases 3 more neutrons. If more than one, on average, of those neutrons goes on to hit another uranium-235 nucleus, the same thing happens again, and you get what's called criticality. Criticality is where you get this vast increase in the amount of energy being released, and you get a graph that looks something like this, and that ends up something like that. This graph, this red hockey stick graph, I want you to note and keep in your mind as we go through the rest of the presentation, because you'll see a few more of them. And I want you to remember where it ends up. Now, I think it's pretty lucky, at least for Chicago, and maybe not for the rest of us, because Chicago survived because these guys knew what they were doing. They managed to control this reaction, and it did not go critical. The apparatus they use is here. It's sort of modern, exciting piece of apparatus made of old railway sleepers, big blocks of graphite, uranium, some boron control rods, and so on and so forth. But this is what was called an atomic pile. And as I was looking at it, I was reminded of what I call a data pile. This was the data pile that I drew back in the mid-'80s, in 1986 to 88. And you notice that, although I wasn't aware of it at the time, it sort of has the same shape. Here we have a big box of stuff, and here we have another big box of stuff. So I was thinking that we probably should call our data warehouses data piles. Probably better than data lakes, don't you think? So look at our atomic pile. You think, okay, is it good, is it bad? Well, actually, if you think about it, of course there have been accidents, of course there's been dangers, of course there's a lot that you can say against it, but at the end of the day, it's been the beginning of a new era. It ushered in the era of nuclear power, and in most cases it has been pretty good for society, for humanity. Can we say the same thing for our data pile? Here's what we're doing with it. Mostly it's about sell more stuff. Is that good for humanity? Is it good for the ecosystem? Is it good for us? Certainly good for if you're a marketer. But we probably need to start thinking about what does it mean if we're creating a data pile, if we're creating this ability to do so much with data that we could never do in the past. So this is where I want to take us. Well, I want to talk about criticality. I want to talk about chain reactions. I want to talk about what happens when you unleash all of the power of data and data modeling. And the first thing I want to show you is where we're going, because here's a small piece of advertising video that I found on the internet that I think is interesting.
As a marketer, you want content that will persuade customers to click and buy. But how do you know which variation will work best? An A/B test? What if the copy is just bad versus worse? What if testing wasn't necessary at all? We use math, data, machine learning, natural language processing, and emotional language data to generate the most effective marketing content. Millions of permutations are created, and a representative sample of message variations are chosen and tested to understand at a granular level the words and phrases that drive engagement. And finally, you're provided with an amalgamated best message to use across paid, owned, and earned campaigns.
So we now have enough data about how people react to different pieces of information, data about what pieces of information to show at what particular time, that we can start predicting how it is that people will react to particular messages. And this is something that you might think, well, marketers and salespeople and advertising have been doing this for years, but now it's been automated. And when you start to automate stuff, it gets faster, it gets a lot more invasive. And so this is one of the things that we need to start thinking about as to where we're going in terms of this new world. And so we do have this new world. We have essentially the dawning of a new era of unlimited information, of unbounded action as we move from data warehouse to artificial intelligence. What was that? Are we in a pokey zone? Have you got your mobile phones out? Come on, guys, let's go. We've got to. I was in Melbourne a couple of weeks ago in a park in Melbourne, and I was watching all these people wandering around. Hundreds of them wandering around, looking at their phones. This is nothing to do with data. It just amused me, and it shocked me because everybody was so totally disconnected from the world and from their people that they were with. And you'll see some of this coming up next. Many of you have seen this picture before, or pictures like it. This is a picture of data growth. The graph itself comes from IDC's Digital Universe study, which has been running from about 2007 until 2014. They have basically been looking at how much data is there in the world and projecting it out, and here's our second hockey stick. What they're saying is that this growth in data is going to go to about 44 zettabytes by 2020. I have no idea what a zettabyte is because it's just too big to even think about. This green line down here is our traditional information. On a scale like this, the growth that we have in traditional, transactional, operational, informational type of information, the stuff we model normally, the stuff that we put into data warehouses and databases and operational systems, you cannot see the growth on this curve. Everything is happening up here. We've got criticality emerging in the size of data that we are collecting and using. And of course, people like Gartner and people like vendors say this is a great thing. So you get statements like this. By 2016, IoT hardware spending has reached $2.5 million per minute. Yay! By 2020, 1 million new IoT devices will be online every hour. Really? Is that good? Is it bad? Who knows? But at least from a Gartner point of view, it seems like something worth celebrating. And yet what's going on here is actually quite scary. What we have done so far from the beginning of data warehousing is to automate all business transactions and gather them and put them all into our data warehouses. What we have been doing over the last few years as we've been starting gathering all real-world messages going through the social media world, all of the events and measures that are being captured by Internet of Things devices, all of that stuff is being captured and stored and put into our data lakes, data piles, data warehouses. And increasingly, all human behaviors and emotions are ending up there too. Some of you may be aware that there is already a lot of work going on analyzing videos for what does somebody think and react to a particular message. It's good science, but it's dangerous science. Because these things are the foundation of all knowledge and power. So in our world, in our data warehousing, data modeling world, we've been used to what's happening here, and this is the business view of the world. What's happening here on the left side? We do consolidated reporting. We start blending operational and informational needs, you name it. We bring it all, and we're now in the area of doing sentiment and relationship analysis and IoT and operational analytics. And you know, this is sort of business stuff that we're used to. But if you look here on the right-hand side, and I've done my little projection beyond today in 2016, we're looking at words like cognitive computing, deep learning, algorithms, and automation. And they're things that are really on the brink of breaking through. And when you guys think about the way that you do data modeling and the way I do designs of data warehouses and BI systems, when you start using words like deep learning and algorithms, this is a whole new world. This is a different world from what we're used to. And yet, if you look at it, we have gone essentially from, and this is the BI world, in structured report and querying through all sorts of modeling and models, to latent and embedded models, to eventually to artificial intelligence. We're on the fringe of that. And even from the world of big data, of exploring big data, we're going through statistics, we're going through heuristics, and we're ending up in the same place. All of the signposts are pointing in the same direction. And that direction is artificial intelligence. And I think one of the more obvious places where you see this happening is in autonomous vehicles. And I'll start with a little bit of autonomous vehicles and then move from there.
The self-driving cars that are on the road today continue to rely on very expensive sensors and clunky software. Hatz's car uses similar sensors like LiDAR for training his AI software, but the cars he plans to sell one day will only need a set of 6 smartphone cameras that cost $13 a pop to see the road, and Hatz's software will take care of the rest. He thinks the total cost for his self-driving package will be about $1,000.
How do you teach a car to drive? Some people might think that what you do is you give it all these rules about driving. You tell it all these, if there's a car a little bit over there, you should give it a little bit of space. And, if there's and there's like very rigid rules, like you should stay in the exact center of the lane. But this isn't how humans drive. This might be how humans think they drive, but it isn't how they actually drive. So how do humans learn to drive? Well, they watch other people drive. And then they try it and they get better. And that's exactly what we're doing here. So right now we're just in the watching phase. We have not told this car anything about driving. We've shown it 10 hours of human driving footage, and we're like, here is what the human did. Behave like that human as much as you can, right? And you get all this intuition that you'd never get in a rule-based system.
I know that that's last year's video, and of course a lot has moved on since, and we'll talk about it in a moment. But what I thought was interesting about it is, first of all, this guy's just a lone hacker. He's not Tesla, he's not Ford, he's not Google. And he's built in his garage or garage. I'm not sure what you say in Berlin. But in his garage, that's the US version, right? He has built a self-driving car. And as you heard him say there, essentially it took 10 hours of driving training and he put it on the road. And as that article in Bloomberg, and you should go and read it, it's available on the internet. As that article said, after 10 hours of training, this car was driving pretty much like a learner driver, about 17-year-old out in the first few times on the road. 10 hours. You can imagine how far this can go. You can imagine how far this type of training can go. And he's taking it from an AI, very strictly AI point of view. Some of the Tesla stuff may or may not be, some of the Google stuff may or may not be, but strict AI and advanced AI in what he was showing there is really teaching cars how to drive, allowing them to learn how to drive on the highway without being given sets of rules. And this is where the change is coming. This is where the change is happening as we start moving from programming to machine learning. So essentially, we're being data-driven. These cars are data-driven. The data's coming in from the sensors and it's being used to make decisions, where to be on the road, how to get around the corner, how to avoid that pedestrian, how to hit Donald Trump. It's information informed. The maps, all of the amount of video footage is being shared among the cars in order to be information informed in terms of making the instantaneous decisions, etc. So we've got here within these vehicles tactical and real-time decision making, stuff we talk about all the time in business. So you can, in some sense, see that business, these cars are a metaphor for business. And you can play with that, and I've played with that metaphor, and it's really interesting to take it to the limits and see where it goes. But we're really now seeing what I think is the death of the old order. Because what we're about to see now, and I want to show you now, is technological disruption and displacement of the world as we know it. A few years ago, Travis Kalanick, who's the CEO of Uber, made a statement in a conference. I think this was about 2013 or 14, and he said he would replace human Uber drivers with a fleet of self-driving cars in a second. I caught that at the time, but it now seems to have disappeared off the internet because he had a problem with that particular message, because he was also going out with the message that he was going to employ lots and lots of Uber drivers in every city that he went to, and that was a good thing for employment in these various cities. But as you probably know already, it's changed. Back then, of course, autonomous trucks had just appeared on the roads of the US. Back in 2015, the first self-driving trucks appeared there. And various estimates suggest that 4 to 8 million jobs in the US could be displaced by autonomous driving vehicles, trucks, vans, etc. This is huge. That's about 10% of the US workforce. Can you imagine taking 10% out of the workforce of any country over a period of 5 years? 10 years maybe? The social implications are huge. Of course, in September, recently, what is it now? About 3 weeks ago, 4 weeks ago, the first self-driving car started picking up passengers in Pittsburgh. They still do have people sitting close to the wheel, just in case, but they're essentially self-driving. John Zimmer, who's the CEO of Lyft, of course, had to respond, and he wrote, therefore, an article in Medium.com, which is not quite as good as getting self-driving cars on the roads of Pittsburgh, but what he said was that autonomous vehicle fleets will account for the majority of Lyft rides within 5 years. And by 2025, private car ownership will all but end in major US cities. Hard luck, Steve. You've got to sell that old banger you got and get the new self-driving, old singing, old dancing car. It's amazing, eh? A few years ago, futurists were writing books, and I've got some of the books in 2010, 2011 saying, we will never manage to get robots to drive cars. We will never do autonomous vehicles. Now we have them on the roads. And it's not just vehicles. Some of you may be aware of this particular demo. This is from Google DeepMind, AlphaGo, who challenged, this is a computer obviously, it challenged the world champion Lee Sedol at Go in a test match in March of this year. Go is one of these artificial intelligence benchmark games. It's a very simple game. It's a strategy game played with, as you can see, black and white stones. But it's played on a grid of 17 by 17. And it is said that there are more potential positions in a game of Go than there are atoms in the universe. So it doesn't really respond terribly well to brute force type of computation, as Deep Blue did in terms of beating the chess champions back in the 90s. So this was the game. It was set up in March this year. Lee Sedol, before the match, said, I believe human intuition is too advanced for AI to have caught up yet. I don't make mistakes often, but if I make any single mistake as a human being, I might lose. It was a strangely mixed message type of statement. On the one hand saying, I don't think I can be beaten, and on the other hand saying, yes, I can. The outcome? AlphaGo 4-1. But more interestingly was some of the comments that people made observing the game. Beautiful moves that do not fit into the usual human style of play. Not only a machine that thinks, but one that can learn and strategize. Now you may debate whether there's some marketing in there, you may debate whether there's a bit of hype, and you know if you've been in artificial intelligence that there's been a number of artificial intelligence winters over the years, and are we overhyping and getting into the next winter? Who knows? But this is big breakthrough. In terms of the AI world, this was not expected to be done for another 3 to 4 years. Suddenly, we are moving so fast that it becomes really scary. And of course, everybody talks about robots and robotics, and we couldn't have a presentation here without some robotics. So manufacturing robots I've just had a blank, his name has gone out of my mind, coming out of the cages, being manipulated by humans to learn, to be trained, and just working on production lines, doing the same sort of jobs as humans, packing boxes. It wasn't possible a few years ago. We have robots moving into the front office and home. We have this guy, Pepper, the first humanoid robot designed to live with humans. And there's been a few since that one as well. What are we doing here? What are we trying to achieve with this? Well, I think this is what we're going. Some of you have seen this before, I'm sure. He looks drunk, but he's not. I always when I play these clips, I always watch the audience reaction. When that first robot is knocked down by that guy with the big stick, my wife can't watch it. She says that's not fair. That's no way to treat somebody. And I saw some people actually be underneath the laughs, feeling a little bit uncomfortable about what they were seeing. Because you start attributing human characteristics to these machines, and I start to say words like he, because they're human-like. The other thing was the second piece, which is that spot. What you saw was that very interesting that the robot didn't quite let go of the can of soda. So there was a sort of a confusion between the human and the robot in terms of what was going on there. But you also saw, I think, the human going, oh my God, did you notice? So there's a lot of stuff going on here that we really have to start thinking about. And you think, why am I telling you data modelers this? Because this is the sort of stuff you're going to have to start worrying about in your businesses, in the applications that you are supporting, in the data that you are making available to your business and how they use it. And taking it into the area where I'm most familiar with in terms of business intelligence. So in terms of data warehousing and business intelligence, we have this movement towards cognitive computing or algorithmic decision making, driven by the sort of advances I showed you in cars and in robotics. So augment human cognition with novel models that interact naturally in exploration and discovery, create and make sense of highly complex data within that context, and expose insights that humans are maybe not likely to notice, or proposing alternative solutions. So that's augmentation. Then you have the, if you like, the automation of decision making, which says, I don't just want to help you to make decisions, I want to get you humans out of the loop because you're too slow, or you make mistakes, or whatever it happens to be, or you're too expensive. So automating decision making eliminates human intervention and speeds up business processes based on continuously improving self-learning models of what's going on in the environment. So we are seeing what I think is a complete and utter change in business intelligence and data warehousing coming over the next few years. I'm a consultant, so I have to have a 2x2. So this is my 2x2 for this presentation. We're going to have a look at operational systems, business intelligence, analytics, cognitive computing, those type of areas against two axes. On the x-axis, we've got hard data and soft information. So this is about information complexity. On the y-axis, we've got problem complexity, and we can think about the simplest problems being deterministic and the most complex problems being ambiguous in terms of their outcome. And what we're seeing is that modeling and algorithmic complexity increases as we go up that arrow. And we can start thinking about how augmentation and automation fit in here. Essentially, with deterministic type of decisions, as we move to softer information, with cognitive computing, we're simply going to see automation, increasing automation of the simpler decisions with the deterministic type of outcomes based on more and more complex information sources. We're seeing that already. That's happening in operational BI already. It has been for a while. In the area of the more ambiguous problems, augmentation is still going to play a role. Now, I believe that the, if you like, proportions between these two arrows is really still up for grabs. I've drawn it this way because my PowerPoint skills are not good enough to really start moving them in the way I'd like to move them. But essentially, the more that business can automate stuff, the more profit there is in it. So there will be a lot of talk about doing augmentation And certainly there will be areas where augmentation, as in computers helping humans, will still continue to be valid. But increasingly the drive is going to be to have automation, because that's what the economy says. That's what the economics and the profit motive says. And we're going further. We're moving into this area called affective computing, which is about understanding emotions and influencing reactions. It's about moving from marketing to manipulation.
And it's with this science that we can transform missing an opportunity into sparking a connection. And for being careless, into being reminded of what matters most.
How do you feel about being manipulated by an algorithm? Go for it? Yeah, I see some people nodding their heads saying, I'll go for that, I'll buy one of those. Okay, I'm just obviously in the wrong place. And now we've got modeling moving beyond data. There is a developer in the US who is building Robotics, robotic AI-driven heads that will be commercially available in 2 years, priced around $10,000, that are put on top of robotic bodies. And I'm not going to leave it all to your imagination.
Hello. My name is Denise. I look forward to getting to know you. Now, touch me. Seriously. I'm not joking. Touch me. Touch me. Touch me. Touch me. Touch me. Touch me. Touch me.
Well, you know what sucks? You have to take the wig off. Yeah, because I got to reboot the Bluetooth again. So next time we'll make that more accessible. There's several aspects to this project. One is the robotics in terms of animatronics and getting some facial expressions and head movement out of the doll. The other is the AI, the customizable programming of personality. What is she saying to me while I'm doing this? Is she enjoying this? Does she like making me feel this? And if you can create that illusion or that experience that she actually likes it, that's going to be a much more impressive payoff than, wow, I can't believe she's gyrating her hips by herself. With the AI, I think we got to be careful with that. Getting the doll confused when you're talking to her and she says some things that make absolutely no sense, which that could ruin the whole build-up. And you never want to go to the bedroom because you think, gosh, my doll is dumb. You want to have that illusion that she's actually talking to you and that she's, got sentience. That's what overwhelms me. That's what takes the longest. I want to have people actually develop an emotional attachment to not only the doll being the robot, but the actual character behind it. To develop some kind of love for this being.
Do you want to look away, or do you want to step closer?
So do you want to look away, or do you want to step closer? What, you're frozen? So we think of this sort of stuff as Hollywood, right? We've seen the movie Her, we've seen some of the other movies that have come out over the last few years about relationships between humans and robots. So there are people trying to do it. There are people trying to manipulate your thinking. There are people trying to influence your thinking. They're not just marketing people. There are people building these robots to say, what can these robots do that is indistinguishable from a human? And when you got to think about that, you got to start thinking about, are they sentient? Are there robot rights? The EU is looking at that, right? This is all sort of crazy stuff that I could not have stood up and talked about seriously 3 or 4 years ago. This is moving so fast that we really are not paying attention, close enough attention, to the implications of what this means, socially, economically, ethically, etc. So I want to spend just a little bit of time talking about that before wrapping up. What are the ethical? How could we get to ethical economics? How could we get to moral management? What do we need to do to think about and use data in a more ethical way? How do you guys in your data modeling day jobs think about the implications of what you're doing and what you're releasing in the world? Think about the scientists back in 1942 wondering what was going to be done with the nuclear energy that they were unleashing. Because what you're unleashing today is probably more powerful than what was released and unleashed in 1942. Essentially, I believe that we are in the process of destroying the old or current economic model. So the old model is essentially that human work produces goods and income buys those goods. And there's a very close connection between those two things. In the business model, automation reduces the cost, therefore increases the affordability, but it also displaces labor. Up until now, the implications of displacing labor have simply been that those workers will move on to somewhere else. They'll find a job somewhere else. But we are actually changing so much in so many industries so quickly that this piece, displacement of labor, workers moving to new industries, is becoming much more unlikely, almost impossible. So that means that automation and algorithms, which are the basis of what's going on here, essentially are breaking the model. So capital, which is the technology, is increasingly used to produce the goods, and therefore work becomes unavailable or poorly paid. And you've seen this. This is not new. The question is how fast it's going to change and whether it's just going to be a blip and go away or whether it is going to be the new reality. And I hate to be the person standing here and saying doom and gloom. It's going to be the new reality. There is not, that I can find, another set of jobs to replace the ones we are displacing at the moment. So then you've got the lack of income to purchase the goods. And at that stage, sorry, my microphone, this is an interesting microphone, Pam. So the lack of income to purchase goods means that there's no reason to produce them, which means that the profit motive goes away. And so we have the third of our hockey sticks. This is the hockey stick which shows the performance of technology versus the performance of humans. The performance of technology in most things that we can think about is increasing so fast and is on an upward curve because of Moore's law, because of big data, that we're really about to cross this threshold. When we cross this threshold in enough industries and in enough jobs, there is no more employment, or at least not enough to make a difference in the world. Of course, there'll still be jobs for data modelers. Really? How much of what you do is unique? How much of it is not automatable? Wordscape will help. So you've got this crossover coming. Robots will eliminate 6% of all US jobs by 2021, starting with customer service representatives and eventually truck and taxi drivers. Forrester, a month ago. Sorry to do this to you, but Karl Marx was right. So what are we going to do about it, guys? We're the people on the front row. We're the people who are enabling it. IT guys, modeling guys, BI guys, people who build the robots, people who do all of this stuff. We are the people who are enabling this transition. What are we going to do about it? Well, I don't have all the answers. I wish I did, because if I had all the answers, I wouldn't be standing here speaking. I'd be moving to New Zealand or something. I hear that there's a lot of rich people setting up in New Zealand and building airstrips, but that's another day's work. I think we have to reinvent the foundations of society. And these are just three things that I come across regularly as I look at this. One is something called universal basic income. Sorry, Steve, that was taken up by Bernie Sanders, but he didn't quite make it, eh? An income unconditionally granted to all individuals, that means test or work requirement, driven by technological displacement and enabled by redistribution of wealth generated through capital and technology. If the current economic model is not working, which essentially interlinks work, payment, and purchasing, then you've got to have something like this that enables people to buy the stuff that you're going to produce. And I don't know why the economists, the mainstream economists, can't see this relationship. The Nobel Prize for Economics went to two guys who did work on contract theory. What has that got to do with this serious stuff? Collaborative commons, cooperative global sharing and interconnection driving towards zero marginal cost production. This is a guy called Jeremy Rifkin. Well worth reading in terms of what one might do in a situation where society is changing completely. Henry Mintzberg, a management consultant I used to quote back in the 90s, has now moved on, has written this book called A Rebalancing Society, where he's starting to talk about the possibilities of what he calls a three-legged stool, public, private, and plural, trying to talk about people in community doing stuff because they're in the community, as opposed to the government doing it or private enterprise doing it. So there is thinking out there, but it's still very marginal. And there's enough people in this room to start influencing it. And there's enough people in this room to start influencing Gartner even. Algorithms will eliminate the last weak link in decision making, us. This was a statement by Rita Salem, who is one of the Gartner BI gurus, as recently as March. Why would one want to do this? And what are the consequences of doing it? What are the answers to the questions like who defines, designs, and checks the data for bias, intended or unintended, if we are removed from decision making? Who can monitor these algorithms for changes in behavior due to hacking, due to their own self-improvement, if we're not involved in it? As machines make ethical choices, who am I going to knock down if I have to choose between the old lady crossing the road and the troop of Boy Scouts on the other side, or saving the driver? We often joke about this as a question for an autonomous vehicle, but it will eventually come up. So as machines make ethical choices, who decides what their morality should be? If it's Elon Musk, if it's the guys at Google, if it is our hacker, George Holtz, are you feeling comfortable? What about the Uber folks who really want to drive all the cars in the world? This is scary. This is the sort of thing we need to think about. And we need to think about it not just in cars, right? This is about our BI systems, moving them to be automated, moving them to be cheaper, moving them to be algorithmic. We're on this path. We're way down this path already. It may be too late, but we should at least stop and think. So I want to wrap up with an old story, and it's an old Greek story. Some of you may know. It's called Pandora's Box. How many of you know about Pandora's Box? Wow! Classical education in Germany is top class, I see. When I asked this question in the US, sorry, Steve, when I asked this question in the US, nobody knows it. Steve, do you know the story? I haven't. Okay. Have you seen the Disney version? So the story of Pandora's Box, of course, is, as you know, that Zeus, who was the chief bottle washer among the Greek gods, gave Pandora a gift on her wedding day. It was actually a jar. In the Greek version, it's pithos, which is a jar, but for some reason it got translated into box in English. So he gave her this box, and of course he told her not to open it, which is, well, it's a bit silly actually to give a woman a present and tell her not to open it. It's like, yeah, that's not going to work. And so we have been given the box. We have the box in our hands. And in fact, we have begun to open it. And indeed, Pandora, of course, did open it. And what happened? Out of the box flew all the evils of the world. You may know of Pandora's box, but I'm not getting a good impression that you actually know the content of the story. So out of Pandora's box, when she opened it, all the evils of the world flew out. And being the good girl that she was, she jumped up on the lid and tried to close it again so that no more evils would come out. And eventually she did close it, and there was one thing left in the box. Hope. Wow, okay, at least 4 of you knew the answer. One thing was left in the box, it was hope. So I hope that I have given you something to think about. I hope that you have taken away something other than doom and gloom from this presentation, and I hope that you can take it back to your work in the next few days and really start thinking about how do we do something about this. Thank you very much.